Welcome back to the second of my MBR videos. My first video was about the general conditions for using an MBR plant, or more correctly, a comparison between the conventional activated sludge plant and the MBR. Then, at the end of that video, I promised I will do a video about operating experience. And this is what we will look at now from 3 plants in Germany, which at the time of my visit had been operating for about 10 years. Before we go into the operating experiences, I would just like to extend a thank you to the treatment plant at Nordkanal and Dr. Ingenieur Kinga Drensla, and also Diplom-Ingenieur Andreas Cano, and to Mito Kanai at Kubota, who was very helpful in setting up the site visits at the treatment plants at Sludge and Woffelsbach. So thank you, and now I will go over to the operating experience. 3 German wastewater treatment plants using MBR, and I'm going to go through these 3 plants in regard to the following: why they choose the MBR, the treatment process at the 3 plants, the flux, sludge and sludge age, quality of treated water, cleaning of membranes, life expectancy, operation costs, personnel, and we're also going to end up with a short summary of these operating experiences. I've picked these plants for a reason. They represent a span of loadings to the treatment plants. So let's have a look at the design condition and when they started. The treatment plant, or Kläranlage Woffelsbach, is designed for 6,200 PE and started its operation in 2006. And it's using flat sheet membranes. The Kläranlage Sludge, treatment plant Sludge, is designed for 11,000 personal equivalent, and it commenced its operation in the year of 2004. It's also using flat sheet membranes. Then finally, a somewhat larger plant to end up, it's the Gruppen Nordkanal, the treatment plant Nordkanal, which is designed for 80,000 PE and operation started in 2004. This plant is using hollow fiber membranes. In my first video, I gave certain reasons for choosing an MBR system instead of a conventional activated sludge system. Now we're going to look at these 3 plants, why they selected the MBR system as their treatment steps. If we look at Sludge, you had an increased loading, which meant you need to expand the treatment plant and you needed more space, but you had limited space to extend a conventional system. Also in Sludge, they had problems with the sludge, with sludge volumes very often exceeding 150. They had a recipient that was very sensitive to take into consideration, and also they actually did a pilot trial test before embarking on the MBR travel, so to speak. In Woffelsbach, you had similar reasons: increased loading, limited space, a sensitive recipient. And for Nordkanal, the slightly larger plant, you had increased loadings, limited space, sensitive recipients, and also here you made pilot trials. So here you can see the reasons, or the combined reasons, for these different treatment plants selecting the MBR. Now we'll have a look at our first plant and the layout of the process step in the plant. The one we start with is Sludge. On the picture you see the screens, 3mm screens. You have a grit chamber, Fett- und Sandfang. Also you have a retention basin at high inflows. And then we come to a part which is also very important, which started out as a BioP step in order to use the BioP process to reduce the phosphorus. However, during operation they found that they needed to strengthen the pre-treatment step in order to protect the membranes from fouling. So in 2006 they changed the anaerobic process to basically a pre-treatment, a pre-sedimentation step to protect the membranes. So in Celshite you have the screens, 3 mm, grit chamber, pre-treatment step, biological treatment, and then you have the membrane steps. With that, let's go to the next plant and look at the process layout of that. Woffelsbach is the next plant we're going to look at the process layout, and as you see it has quite similarities with the Celshite plant, but let's have a look at the process layout. Here you have a screen, 3 mm screen, you have a grit chamber, and then finally a 1 mm step screen. Then you go into the biological treatment step, which in this case is a racetrack. And after the racetrack you have or connected to the racetrack, you have the membrane step. So you have the screening, grit chamber, also a 1 mm screen here, as opposed to in Celshite where you 3 mm. But this again, what you choose for the screens of pre-treatment is of course very important what type of wastewater you have coming into the plant. But the basic line is that you need to have a sufficient pre-treatment to protect the membranes. With that said, let's go on to the biggest plant we're going to look at now, the Nordkanal plant. Here in the Nordkanal plant you have a layout that looks like this. First you have the screens, which you of course recognize from the other plant, which is about 3 mm. Then you have the grit chamber, and then you have 1.5 mm screen before you go into the biological treatment step and the final MBR step. And in Nordkanal, lots of experiments and tests have been made in order to find an optimal pre-treatment for the MBR. As you see, you have the screens, you have the grit chamber, or you have a pre-treatment. But independently, as I said, it's very important that the pre-treatment process protect the MBR, the membrane steps itself. Flow, flux and permeability. Very important key parameters, as I mentioned in my first videos. And for the different plants, we are going to look at these parameters now. Just to explain the table for you, you have the treatment plants here, Cellshites, Woffelsbach and Nordkanal. The MED-F is average flow, Max-F is maximum flow, Mem-Yta is membrane surface, and Perm-B is permeability, and finally flux for the different plants. So let's have a look at Celshite here. The average flow is 20 liters per second, maximum flow is 100 liters per second. And the total membrane surface is 12,480 square meters, and the permeability is between 300 to 600 liters per square meters hour and the bar. And also the flux 27 liters square meters an hour. And the one here notes that it's a yearly average and it's not normalized for temperature here. In Woffelsbach you have the average flow 43, maximum flow 88, total membrane surface 13,440, and the permeability 200 to 450 liters square meters an hour and bar. And the yearly average flux is about 20 liters square meters an hour. And for Nordkanal, we look at the figures here. You have the average flow, 284, and you can see here the rest of the figures. And finally, the flux over the year, which has been normalized to 20 degrees Celsius. It's between 20 to 30 liters square meters an hour. So when you look at this table, what would I pick out, or what would I note here? Well, definitely the permeability, the operating pressures, but also I would say the flux that you can see in these plants, which ranges about 20 to 30 liters square meters an hour. And these plants are of course operated in not so, how should I say, not Nordic conditions, but in Germany you have winter, summer, and also you can have rather cold water coming into the treatment plants, and during summer of course a little bit warmer water. But for, how should I say, Northern Europe conditions, if you look at the flux here and you're thinking of having, how should I say, a key figure, or if you want to note how much membrane surface do I need if I want to have a plant of this size, then I think you can look maybe to 20-30 liters square meters an hour to make a very rough assessment of the membrane surface you need. And of course, membrane surface is what will cost you, independent if it's flat sheet or if it's the hollow fiber membranes. Sludge concentration, sludge age, especially sludge concentration when running the biological process is of course very important. It will give you the treatment conditions. Also, the aeration and the efficiency of the aeration is dependent on the sludge concentration. With MBR, as I mentioned in the first video, you don't have any worries about bad slosh or overflow of sludge because you have the membrane as a 100% stop for excess sludge going over to your treated water. However, let's have a look at these parameters in the three plants we are now looking at. Here you have the table where you have Sludge, you have Woffelsbach and Nordkanal. And I would say you can look at the sludge age, which ranges between 25 to 50 days. Here you have the sludge concentration that they were operating at the time. And it somewhere around maybe 10 to 15 grams per liter. So it's at least double or double and a half, 2 times the normal concentration you will be running at in a conventional activated sludge plant. And of course this comes to the size of the plant, but also you have to keep in mind the higher the sludge concentration, the lesser, or how should I say, more or less efficient alpha value for the oxygen transfer for the aeration. So high sludge concentration has a side effect of a lower alpha value, that is a slightly higher cost to transfer the oxygen to the bacteria, which you always have to keep in mind. And hydraulic retention times minimum here is between, well, 4 to 5 hours for the three plants. But I think focus here is on the sludge concentration that the plants are running. And can I say typical? Well, I don't know, but somewhere around here you will have, you can find operating sludge concentrations for MBR. You can of course also go lower, you can go higher, but it will have positive and negative effects. The process, sludge concentration. Now let's have a look at the effluent quality from the three plants at the time when I visit them. In this table you see the three plants, Sludge, Woffelsbach and Nordkanal. And in regard to organic material, it is what you can expect from biological treatment and removing the organic material. And typically BOD5 is less than 5 milligrams per liter. Total nitrogen is below 10 milligrams per liter for all the plants, and phosphorus varies between 0.48 0.22, 0.5 milligrams per liter. And here you see bacteria, and also this also demonstrates very clearly the advantage with an MBR. It will give you a treated water fulfilling the bathing water directive, which is one of the things that it's a big advantage if you need it with an MBR. But also, and this is important to stress, if the dissolved substances like nitrate, ammonium, phosphate hasn't been dealt with in the previous process steps before, the membrane, the MBR, the ultrafilter membrane, will not hold back any dissolved substances. It only holds back particulate material and of course bacteria. And I stressed this in the first video when I talked about the membrane and how the membrane works in different types of membranes. But for the MBR, using ultrafilter membrane, it will hold back particulate material and bacteria, but not dissolved substances. What is the most important thing, I would say, my personal opinion, when it comes to membrane operations? Cleaning. The cleaning procedure is fundamental to any membrane operation. That is to keep the membranes free from fouling or decrease the fouling so you have a smooth operation. So let's have a look at the 3 plants, what they're using. Before we go into the different plants, I just wanted to note the chemicals that you have here in the table head. You have sodium hypochlorite, sodium hydroxide, peroxide, nitric acid, hydrochloric acid, phosphoric acid, and well, citric acid. And these chemicals are very common in different combinations when it comes to cleaning membranes. So you will find these in industrial or drinking water production also, and being used differently depending on what type of water and processed water you're running, of course. With this, I think we'll start with celshite here. And celshite is a good example of keeping in mind the effects of the cleaning chemicals when you use them. Celshite started out using sodium hypochlorite, but they discontinued this because they have AOX forming in the effluent water. So hypochlorite was okay to clean the membranes, but it had a secondary effect for the effluent quality. They using sodium hydroxide, peroxide, and they also looked at nitric acid to clean the membranes, but this was discontinued because of the working environment, and which could be a case in some plants, but you need to consider this also. And they also used phosphoric acid, but this had a side effect in the cleaning procedure that it gave slightly elevated concentration of phosphorus in the effluent quality in the case of celshites. So today they're using citric acid, sodium hydroxide and peroxide, which works fine for cleaning their membranes. But they have some very good, or I should say, good experience for showing to keep the whole picture in mind in regard to secondary effect in the working environment and effluent quality. For Woffelsbach, they are using peroxide and citric acid. For Nordkanal, they're using hypochlorite, sodium hydroxide, hydrochloric acid and citric acid in a combination to have a good cleaning of the membranes. Now, finally, we're going to look at these, the end of the table here, the CIP, cleaning in place, per annum, yearly. And for celshite, they have one cleaning in place, which is more extensive cleaning of the membranes, but it's done within the tank, so you don't have to take the membranes out. So it's pretty straightforward, but it's a more extensive cleaning than the daily routine cleaning and flushing of the membrane. Woffelsbach, you have 1 to 2 yearly. And in Nordkanal, you have 52 cleaning in place over the year. And this is, of course, due to the fact that you have flat sheet membranes and you have hollow fiber membranes here, which you need to consider in regard to the cleaning in place. And again, it doesn't say that flat cheese is better or worse than hollow fibers, but it's different conditions for operating the membrane. So when you select your membranes, you need to consider all the aspects of the process, of course. Now, cleaning out the place is in Cellscheid not done. And cleaning out the place means you will take the cassette or the cassette with membranes out of the tank and make a very thorough cleaning of the membrane, mechanical and chemical, of course. In Woffelsbach, it happens once every year. In Nordkanal, well, half a year up to 2 times a year, depending on the conditions. So 2, how shall I say, major cleaning procedures: SIP, cleaning in place, and cleaning out of place. And again, more frequent for the hollow fiber due to the type of membrane and the way they are set up. Now we come to a very interesting question. How many of the membranes have been changed during this time of operation in the 3 plants? In the wastewater treatment Cellscheids, with a loading of 11,000 PE, less than 0.01% of the UF membranes had been changed over a 10-year operation time. For the Woffelsbach treatment plant, with a loading of 6,200 PE, less than 1% of the UF membrane had been changed over a 9-year operation period. And finally, for wastewater treatment plant Nordkanal, with a loading of 80,000 PE, less than 0.1% of the UF membranes had been changed over this 10-year operation. So you can see here that it's a good track record for the membranes in the plants with, well, let's say a practical lifetime of 10 years. Now we're going to look at the operation costs for the plants. And in the costs I will show you, everything is included. That is the chemicals, especially energy consumption, personnel, and everything that goes into the operation maintenance of these plants. For the treatment plant Cellscheid, in the beginning there was an operation cost of 1.74 euros per cubic meter, but changes in operation, that was cut down to 0.72 euros per cubic meter from 2004 and onwards. Treatment plant Woffelsbach had an operation cost of 1.60 euros per cubic meter. And here in Woffelsbach, which is a very nice tourist place, there are very elevated loading during summer, which is one explanation to the operation cost. And for the treatment plant Nordkanal, the cost was 0.28 euros per cubic meter. Now, these figures are from a 10-year period of operation, of course, but also there are constantly improvements in the operation of MBR, especially when it comes to the aeration scheme in order to keep the membranes free from fouling. And I know that the last years, especially I know in Nordkanal, they have worked a lot to cut down the energy cost in regards to the aeration, which they also have been successful with. But keeping in mind the operation cost and also the lifetime of the membranes, this is giving you an indication of the operating cost. Smaller plant, maybe higher operating cost, of course. Bigger plants, it decreases. But some guidelines or some ideas in regard to the cost for the MBR operation. Before I summarize, I will also show you the staff at the different plants. And just a note that I made these site visits in 2014, so they have some years on the shoulders, these figures, but these are the figures that was valid for the 10-year operation time at the plants. In the treatment plant Cellscheid, there was 1.5 person during daytime and 1 person standby weekend and nights. And at the time in treatment plant Woffelsbach, there were 1 person daytime, 1 person standby weekend and nights. And for the bigger plant at Nordkanal, there were 6 persons during daytime running the plant. And a note, that was the same amount of people as before the extension of the plant and the introduction of the MBR system. Also, there were 2 persons from the research and development department for making the optimization of the process. And as I noted before, they have done some very interesting and good work optimizing the MBR system, and notably in regard to the aeration and energy cost for the aeration. With that, I will just very shortly summarize. I have shown you 3 plants having operated for 10 years. Also the lifetime expectancy of the membrane, and we can see here that they have basically been working for 10 years in practice. Also personnel operating cost for these 10 years. And I don't want you to take these numbers as fixed, but as guidelines idea when you are looking at, thinking of using the MBR. And also, if you haven't seen my first video with some general information about the MBR, I would advise you to do so, because there you have the background information to these practical experiences. Enough said about that. I hope you could learn and enjoy the video. And with that, I say thank you very much and hope to see you in the next video. Take good care. Bye bye.